Hello guys, this is Zef from Applefix Hamilton in New Zealand. Okay, so we have got today Samsung S7 which is dead. And I have already tested. There's no short on the board, nothing. There's no heating point, and further I have tested with multimeter, and the power IC looks gone. So when a phone is not booting up and no display, nothing, it doesn't always mean it's a power IC, because you have to check other components as well, like if there is a short on the board. So in this particular phone, that is a power IC. So how we tested the power supply, if it's faulty or it's not something else. So for that, it's quite easy. So let's see. So go to symmetric diagram. So this is Samsung S7 board view. So these, you have to check what's the coming out from a power supply. It's like sort of transformer that's supposed to give certain sort of voltage, which it's not giving out. So like this capacitor here, which is C7013. Let's check the line. What's the voltage on this one? C7013. See, this is C7013. So this is a 5 volt line, and on power management IC, and there are other capacitors as well, which are connected to the same power IC. So the voltage on these other ends, which is light blue, are ground. So how we check the voltage? So we have to connect the charging port. Let's take a look here, and we will connect the charging port and the power cable, and then we can measure the output from the power IC, which when I will test it is right, and on some capacitor there is no power. It's not like such a brainstorming thing. It's, if you know how to read symmetric diagrams, so basic use of multimeter, you can find it out easy. Okay, I will connect the power line. I will look on the microscope. I will turn on in DC voltage and see what we are getting out of these lines. So black on the ground, and let's check here. I think you can see the multimeter here. So we have got 4.3 here, and then go to the next one, 4.3, go to the next one, nothing here. So go to the next one, 4.3, that's right. So this is all around, should be 4.3 or 5 volt line, whereas on some, see, we getting nothing here, and then we getting nothing here, 4.3, and then 4.3, and nothing here. And there is another way which is not difficult, I think, easy. So the power IC should be giving 3.5 to 3.7 volt on the battery terminals. So let's check what we are getting here on the battery terminals. Okay, so that should be 3.7 and nothing here. So that is how we come to know, reading these, finding these what capacitors are there, and then finding it on the schematic diagram, what voltage lines are these, and how much current we should get there, which we are not getting. So that makes me believe which is power IC. So you see my face? Yeah. Which is power IC. So let's take the power IC out, and we will be putting new power supply, and hopefully it should work after that. Okay. So the power IC's part number is s535, which is I think same for s6 Edge or s7 Edge and some other Samsung phones. Will put some Captain tape around. You can see it. So again, because it's quite clear from here now, so we have tested these capacitors, and you can check any other as well which is on the same line. So here, see, all these red are on the same line, and you can also check the other side of the board, which, so this is U7000 S535 power IC on S7 Edge. So I will put some Captain tape here. Okay, so let's go here so that you can see. This is quite a big IC. So I think Samsung's phones are much more easier to work on because they have got bigger surface area, and somehow I feel like the board quality is better. So okay. So this is autofocus trying to do something by itself. Wow. Stop it. So I usually mark the orientation of which I can see that dot is here. So I will just mark a little bit here so that when I'm putting the new power IC, I don't have to look at the board diagram or somewhere again. So put some flux. So what flux does? Flux helps melting the solder underneath the IC on a lower temperature. And I usually put some metal plates around the area so that other components, they don't get too much heat. If your Samsung S7 Edge or S6 Edge is not powering up, most probably I think these power IC, like on iPhone 6 Plus, the touch ICs are manufacturing fault, so they were failing. But you have to check each time, so it comes out nice and clean, you can see. In my previous video, I don't usually use, on smaller ICs, I don't use solder braid to clean these leftover solder balls, but this is a little bit, I would say, bigger area, so we can use, let's see how we do it. Because first of all I will be using little bit of low melt leaded solder with a smaller tip of soldering iron, and if it's not cleaned well, maybe we will use this should come. Maybe we will use solder braid, but not at this stage. See how it goes. So I will start cleaning. Put a little bit more flux here, and okay, put a little bit more. For me, I don't think we need solder braid here, so that looks okay to me. And we will use some isopropyl alcohol. Does it look clean to you? It looks pretty clean to me. Okay. Yeah, there you go. Okay, that looks okay, that looks all good to me. But these two, I think I have to give a little bit of clean here. These two here. Okay. Okay, let's put a little bit of flux and just yeah, that's better. So why my microscope is not giving sharp image today? Okay, let's try here. Better? Here it's better. That's fine. So So that is came out pretty nice. So new S535 power IC, take one out. Even though these are, they say it's original and brand new, but still sometimes I have seen even on the brand new ones these solder balls sometimes are missing. So just check it if the IC looks okay. The new one, where is it? Oh yeah. Yeah, that looks perfectly fine. I don't know why some technician they do reballing. I mean, you can get these IC at pretty reasonable price, so why waste your time reballing? Okay, we have already marked the orientation, how the LC will go. See here. So we will put more flux here. Okay. We have got MacBook Air with a backlight problem that I'm supposed to do today. So maybe I will make a video, MacBook backlight. So we don't know if it's backlight IC or something else, but you know, you can see when you put a torch on the LCD, you can see the Apple logo and no light. So there is something wrong on the backlight circuit that I will be doing Monday. So there you go. We'll put it here. So you see they have marked these on the corners. So you have to just hold them. Yep, that's the right way here, and then I can see that is sitting right on both sides. So here. Yep. So I will just move it a little bit here so that you can see. What the hell? Okay, do it manually. Yeah, I think that's should be okay for you. So let's hold the IC on its place and then there you go. You have to have very steady hands to do these sorts of jobs. So I will just take the hot air gun away and just take the tweezer out, and then I have to find my another tweezer so that make sure it's sitting properly. Do it one more time. So I think you would have noticed how the IC has slipped to its right position, and I give it an edge, it's all look good, so that's all done. Okay. So guys, we've been doing it I have been doing it quite successfully, so I can tell it's sitting properly, and should not be not a problem turning on the phone. So the next thing we will be doing same thing again, so just with the multimeter, and the same way you check the schematic diagram, you check how the voltage are on these coming out on these capacitors, and you can also check on the battery connectors. So that's it. So hopefully next time I will be doing video on MacBook Air backlight IC. Why I call it backlight IC? Because unless or until we check it, we don't know if it's IC or something else wrong the board. And if you have any question, you can write in the comments, or if you are in New Zealand and your phone has got same sort of problem and you have taken to the shop, they say no, it's not repairable. Yes, these are repairable. You can send it to us. I will leave a link if you want to send your device to us from anywhere in New Zealand. Okay, take care, bye.